Dear learners, in this unit we will introduce you to computer bus and its types, serial and parallel ports, operating systems for personal computers, microprocessor and its characteristics. After completing this unit, you should be able to define computer bus, define different types of buses and their features, understand the use of different ports, explain different PC platforms, explain word size, cache memory, RISC computing, CISC computing and parallel processing. Dear learners, the computer bus is an electrical path between the components of a computer. It consists of around 40 to 150 electric wires running parallel to each other. There are two types of computer buses, known as the internal bus and external bus. The internal bus connects the CPU and other devices on the motherboard. The external bus is used to connect input-output devices to the CPU. It has two parts that are data bus and address bus. The data bus is used to carry data between CPU, memory and other hardware devices on the motherboard. These can transfer 8, 16, 32 or 64 bits of data in a unit of time. The address bus connects CPU and RAM and carries only memory addresses. Dear learners, the computer motherboard has many expansion slots. These allow you to enhance the processing functionality by adding expansion boards. A number of new bus standards have been introduced with the advancement in microprocessor technology. These include ISA bus, local bus, PCI bus, AGP bus, SCSI bus and USB bus. The most common expansion boards are plugged into an industry standard architecture expansion bus. It was introduced in the mid-80s and is still used to attach slower devices like disks, modem and input devices. Local bus technology is used to attach faster devices to the CPU. It runs between components on the motherboard. Dear learners, Peripheral Component Interconnect Bus was introduced by Intel. It improves the performance of high-speed peripherals for graphics operations and high resolution. It makes it easier to integrate audio, video and graphics. PCI buses can transfer data up to 133 megabytes per second. Accelerated Graphics Bus allows the video card to directly access system RAM. It greatly increases the speed of graphics performance. AGP standard has led to the development of accelerated video cards that support 3D motion videos. AGP buses are rated at speeds in the range from millions of bytes per second to billions of bytes per second. SCSI standard was introduced to overcome the limited number of expansion slots on the motherboard. It extends the bus outside the computer by a cable that allows you to plug multiple devices into a single port. This process is called daisy chaining. Different SCSI standards have been introduced. The emerging standard is SCSI 3 that allows you to link up to 127 devices. The newest Ultra 3 SCSI standard supports 32-bit bus and can transfer data at a speed of up to 160 megabits per second. Another most modern bus standard introduced by Compaq, Microsoft, IBM and other industry leaders is Universal Serial Bus. Some features of USB are to eliminate the need for installing separate expansion cards, plug and play feature. It allows to daisy chain up to 127 USB compliant devices to a single USB port. It allows fast data transfer rates up to 12 megabits per second. Dear learners, external devices including keyboard, mouse, monitor and printer are connected to the computer by using different ports. There are two types of communication ports, that are parallel port and serial port. Parallel port allows parallel transmission of data. It consists of 8 or more wires for data transmission. It uses 25-pin or 36-pin connector. The data travels in parallel over 8 lines. The extra lines carry control signals. Parallel port provides interface for magnetic tape, other computers and high-speed printers. Serial port allows a single bit of data to be transmitted at a time. It uses 9-pin or 25-pin male or female connector. One line carries serial signal to the device and another line carries signal from the device. Other lines carry control signals. Usually the mouse is connected with the serial port. Several other ports are available on the back of the computer to plug different devices. These include SCSI ports, USB port, dedicated keyboard port, dedicated mouse port and infrared port. SCSI port enables faster data transfer and many devices can be attached to a single SCSI port. USB port offers plug and play feature. It is a high-speed port that allows up to 127 peripheral devices to be connected to a single USB port. Dedicated keyboard serial port has 5-pin or 7-pin round connector for the keyboard. Modern motherboards also support dedicated serial port for the mouse. IRDA port or infrared port can transmit data by using infrared light waves. It works within a few feet distance. Dear learners, a PC platform is a standard for which different types of software are developed. Typically, a platform has two key elements, that are the processor and the operating system. The operating system is designed to run on a single platform or, in some cases, on a multi-platform. In cases of multi-platform, the computer runs its native platform and emulates other platforms. Before selecting the platform, it is important to ensure the availability of all required application software and compatibility of the platform with existing hardware, software and expertise. A number of platforms have evolved during the past few years. The first element of PC platform, that is the processor, will be discussed in detail when we talk about microprocessors later in this unit. We briefly discuss operating systems in their chronological order. The first and most powerful operating system is Unix. It was introduced in the early 70s by Bell Labs. Unix was distributed by Bell Labs for teaching and research purposes. This led to development of a number of Unix-based software. These include AUX for Apple Macintosh computers, AIX for IBM workstations, Solaris for Sun Microsystem, OpenVMS for Apple workstations, SCO Unix and XenX. Older versions of Unix provided text-based interface, but now more sophisticated. Dear learners, the second Macintosh operating system had many features. The second PC platform that ruled the world of computers for the last 15 years is Microsoft Disk Operating System. It was easy to use operating system for IBM PC-AT and compatible computers. DOS became inadequate for powerful computing with the advancement in microprocessor technology. These are some limitations of DOS. It was designed for 8-bit and 16-bit microprocessors. It could not avail the advantages of 32-bit architecture introduced in modern microprocessors. It could execute only a single application at a time. It supported only one user and single processor. Another critical limitation of DOS was its inability to access larger RAM. It could only recognize 640 kilobytes of RAM. Additional software was required to access memory beyond this limit. The file name in DOS has certain limitations. DOS provides command line interface. User started switching to other operating systems with the introduction of GUI by Apple computers. Dear learners, the Apple family of the second PC platform that ruled the world of computers. Macintosh operating system had many features like similarity of applications, built-in network support, plug and play support, sharing across different applications. Although Mac operating system works only on Macintosh computers and compatible hardware, it is still the first choice of many users. Realizing the popularity of GUI, Microsoft introduced Windows in the mid-80s. It executed with the support of DOS. Windows replaced the command prompt mode of DOS with point-and-click graphical user interface. Windows was not a complete operating system, but an operating environment. Later on, Microsoft released Windows 3.0, 3.1 and Windows for Workgroups. These were stable software and capable of loading more than one program at a time. OS/2 was another PC platform operating system. It was introduced in 1982 after the introduction of 80-286 microprocessor. OS/2 was a joint venture of IBM and Microsoft. It was GUI-based multi-user and multitasking operating system. It had support for networking. Microsoft switched to develop its own products, but IBM still continues the development of OS/2. In the early 90s, Microsoft released Windows NT for powerful workstations and network servers. It was a 32-bit operating system. Since the network computers fall into two categories, Microsoft released two products that are Windows NT Workstation and Windows NT Server. The main features are Windows NT are: it runs on a large number of systems that use Intel, AMD, Cyrix or other RISC-based processors. NT-based workstations support peer-to-peer networking. It supports both FAT and NTFS file system. It provides disk mirroring features that allow backup hard disks to take over in case the primary hard disk fails. Windows NT Server is another operating system. It runs on server-side computers. It has similar look and feel like Windows NT. It has the features like file and print server, allows better security features for grouping and authenticating users, controlled access to network resources, disk duplexing and disk mirroring, combined storage on different disks to look and function as a single disk. Microsoft released Windows NT Server is another operating system. Dear learners, a microprocessor is a small silicon chip made up of a number of transistors and integrated circuits which work together to process information at an incredible speed. A microprocessor, or CPU, is sometimes called the brain of a computer. The CPU comprises of two main components. These are control unit and arithmetic logic unit. Control unit reads and interprets instructions from main memory, directs the operations of processor components, and controls the flow of data in and out of memory. Arithmetic and logic unit performs all the arithmetic and logic operations. Arithmetic operations include addition, subtraction, multiplication, and division. Logical operations include comparing numeric and alphanumeric data. Performance of a processor depends on a number of features which are word size, number of registers, bus speed, addressable memory, cache memory, clock speed, and math coprocessor. The first feature of microprocessor is word size. It is referred to the size of CPU register. It describes the number of bits that the processor can process in a unit of time. A processor can process large amount of data if the word size is larger. Typically, processors have 16, 32 and 64 bits word size. This graph compares different processors. Modern microprocessors contain high-speed storage locations called registers. These are used to hold data, instructions, and results of operations temporarily. These registers include general-purpose arithmetic and logic registers, flag registers, stack registers, segment registers, and index registers. This table shows some details. Next feature of computer is its bus speed. Computers use data bus to transfer data between components of CPU and address bus to transfer addresses between RAM and CPU. Processors have 16, 32 or 64-bit buses. These operate at 66, 100, 133, 200 or up to 400 megahertz. The next feature of microprocessor is its addressable memory. The figure shows the comparison between processor addressable memories. Modern microprocessors contain high-speed storage called cache memory. Cache stores the data and instructions that are accessed by the processor repeatedly. Microprocessors have support for Level 1, Level 2 and now Level 3 cache memories. Level 1 cache is built inside the microprocessor. Earlier, CPUs supported 0.5, 8, 16 and 32 kilobyte cache memories. Modern microprocessors contain up to 256 kilobytes of Level 1 cache. Level 2 cache is external to the microprocessor. It lies between the microprocessor and RAM on the motherboard. Its size varies from 512 kilobytes to 2 megabytes. Some processor manufacturers have introduced Level 3 cache. The next feature of the microprocessor is its clock speed. Higher the clock speed, faster is the processor. Modern microprocessors have clock speeds up to 2 gigahertz. These are capable of executing up to 2 billions of instructions per second. Microprocessors contain millions of transistors to function at a high speed. This graph compares the number of transistors present in different microprocessors. Microprocessors have become number crunchers and can process very large or very small numbers accurately. For this purpose, microprocessors have support of number coprocessors, math coprocessors and floating point processors. For example, Apple Power PC family G4 processor is capable of performing billions of floating point operations per second. Two processing techniques greatly affect the speed of processor. These are CISC and RISC. CISC-based processors can execute 200 to 300 instructions. Intel and Motorola processors are CISC-based. Apple family of processors are RISC-based. The RISC theory states that if the instruction set is kept small, each instruction will execute in less time. Another concept of processing is parallel processing that allows multiple processors to share the workload. Although the idea of parallel processing is not new to minicomputer, mainframes and supercomputers, these days it is implemented in personal computing. The introduction of dual and quad processing has increased the computing power of today's personal computers.